Hello everybody. This is going to be a really quick video explaining the quote-unquote where will they meet problem that we did in class. It seemed like people had a little bit more trouble with this than I thought, and I just want to clarify a few things. So let's start with the problem first. The problem looked something along the lines of you had two people going to meet each other from their houses, right? We had, I believe, Abby was one girl or one person, and she was walking towards her friend Ben, who was riding his bike. So yeah, that's what that looks like. And so Ben was going at 5 meters per second, and Abby was going at 1.5 meters per second. And I said that their houses were 300 meters apart. So the first step to this problem would have been to figure out a reference frame. In other words, an origin. Where do we want the 0 point to be? This is following the steps of everything we've done in class. So you could have picked any different combination for the origin. You could say that Abby started at 0 and that Ben was riding from 300. You could say that Abby was going from 300 and Ben was going from 0. I'm going to say that Abby is at 0 and that Ben is at 300 meters. You could have said 150 and 150. The final answer is slightly different, but the time is still the same. And so the two parts of the question were A, find the time it takes them to meet, and B, find the location that they meet. Alright, so the first step would be to make a function for both Ben and Abby's motion. We're going to A, B. Alright, so let's do a function for Abby's motion first. So this combination of letters, this idea here is that this is the position that Abby will be at a given time, at any given time. So you plug in a time here, you can find out what position she's going to be in. And so she's starting from the origin. She's moving at 1.5, since we know that the general equation is v for Abby times time plus x initial. X of t for Abby is equal to the v for Abby, which is 1.5 meters per second, t, and plus since her initial position is 0, we just put 0. Now notice this is positive because we say she's moving in the positive direction. If we decided that Ben was at negative 300, she would be moving in the negative direction. But right now she's moving in the positive direction. And so we're going to do the same thing for Ben now. And so Ben's velocity is 5 meters per second going this way, though, which means that he is actually moving in the negative direction because he's going back towards 0 from 300. So Ben's function, or mathematical representation for his motion, looks like this. And since Ben is starting at 300 meters, we would put 300 here, positive 300, instead of 0, because he's not at the origin. Now that we have the two functions, we can figure out where they're going to meet. So if you think about it, the position as a function of time for Abby and the position as a function of time for Ben are going to be the same for whatever this time is. So this is going to equal to this, right? This means that their positions are the same. This is where they're going to meet. So if these two things are the same, then the equations that they are equal to are going to be the same as well. So this is 1.5 meters per second. T is equal to negative 5 meters per second t plus 300 meters. Right? Now we do some algebra, and this comes out to roughly 46.15 seconds. Alright, and now that we have the time it takes, we would just take this and we plug it back into either of these equations. I'm going to take it and plug it into Abby's because it's the easiest. You don't need to include that many decimals in your problem. But there you have it. If you did it where they are going from negative 150 or positive 150, so you put the origin in the middle somewhere here instead, So if you did this, where you called this 0 and this negative or positive 150, and this 150. Then depending on what side you have Abby on, your answer is going to actually end up... The time is going to be the same, obviously, but the answer you should get is either that they're going to be plus or minus 80.7, about 77 meters. If she is on the side with the negative 150, it's going to be negative 80. If she's on the side with the positive 150, it's going to be positive 80. All right. Hope that helps clear things up. And for tomorrow, I wanted to give you another practice problem. So let's say you have two cars. One of them is a Malm rocket, essentially, going at a velocity of, let's say, 25 meters per second. And another car, sports car, is starting 100 meters behind it. The difference in position when we start looking at these two cars is 100 meters, and the sports car is going at a whopping 35 meters per second. So I want you to answer the following things. I want you to draw a position versus time graph for both cars, so put both cars on the same graph. I want you to write a mathematical representation for the motion of each car. Okay? You can call this car van, you can call this car sports car, whatever you want. And then tell me at what point t will the sports car pass the van. And finally, I want you to tell me how far each car will have driven when this happens. So from the starting point, how far did each of them travel once the sports car passes the van? Alright, I'm going to stop there before this gets any longer. See you tomorrow. Bye.